Good morning. Today we discuss about numeric palette in LabVIEW. It is the basic palette. After starting with toolbox or introduction, we go to our first palette, which is numeric palette. So here is my numeric palette. You can lock it using this. So here, this is my programming window. You can say block diagram window, and this is my front panel window. In this numeric palette, we have different mathematical operations like add, subtract, multiply, divide. So one by one, I will discuss everyone. So first, I create a program to add two numbers. So I just create a control. Then over here, create another control. So here is my x variable, which is my floating. Orange color denotes it is a floating type, and y is also a floating, and you can change it also. So go to just representation. So here is different notations or formats, like it is double precision, it is I32, integer 32, it is integer 16, I8. Basically I32 is the range of this number. It is 2 raised to 32 up to which it can measure. Like over here it is given 0 to 31, its range. So over here I create a indicator. So this is my basic LabVIEW program of addition in LabVIEW. Using this highlight execution, you can check the data flow in LabVIEW. The data flow is always from left to right. So when I put some value in this like this, and when I hit on run button, so from here 5 and 4, it give me 9. So this is the basic LabVIEW program. In addition, you need not to consider any precautions, like you can add x plus y or y plus x, both will give you the same result. But in case of subtraction, you have to check which one is your x and which one is your y, because x minus y and y minus x gives you different results. So this is the case, and same case applied in multiplication. X into y or y into x gives you same result, but x upon y and y upon x gives you different results. So these are the four nodes. This one is called node. Okay, this one is our indicator and this one is our control. So right now our next part in numeric palette is quotient and remainder. In this case, you got a floating value which is like 3 by 2. It gives you 1.5. But if you want to check the remainder and quotient differently, for a case like over here, this is my control, this is my control for y, and over here I have input is 3 and this is 2, and in this case here is my indicator which gives me remainder, and this will give me the quotient. Okay, so when I hit on run button, it gives me 1 1, as you see, and when I change it to 5, quotient is 2 and remainder again 1. So using this, you can use this palette. So I cover every part of this numeric palette. So this is my first row, and in this you can convert your one part of data to another part. Like if you want to convert boolean number to number, or number to boolean, or boolean array to number, you can convert using this. I will take an example of this also. So this is the increment. If you want to increment by 1 your value, you can use this. If you want to decrement, you can use this. This function add array elements. So first you note down how to create an array. So first I create a blank array. So over here, this is my array, blank array, and in this I put numeric control, as you see, and in this array I take 4 values like 4, 3, 4, 7 and 8, and I want to use that function of array add array element. So it will add your all the array element, like you have to connect this and it will give you a scalar value, like in this case when I hit on run button it will add all the values. So total is 26. It will add all the elements. So you can use this to add the array element. So next is our multiply array element. So I just use this, and already created array is connected, and this one gives the product of array functions. So like when I hit on run button, here is the product of all the element, 4 into 3 into 4 into 7 into 8. Okay, so now we go to our next function. It is a very important function in LabVIEW. It is compound. In already created functions like add, subtract, multiply, you have only 2 inputs. As you see, in this case you have only 2 inputs. Over here it is 2 input. If we want to add 3 elements, so we can choose this type of function. So first 2 and this one, it will give me, in this case I will add 3 elements. So for that purpose I use 3 addition blocks. So to remove this part I just use compound element, and in this you can add as many as inputs, like in this case. So over here in this compound there are more functions like addition, multiplication and or XOR. This is the basic functions you can use. Using this you can find out your operations of many inputs. Like if you want to add the temperature of 2 buildings, then or 3 buildings, you can use this. For multiple inputs you can use compound arithmetic function, and in this total 5 operations are there: add, multiplication and or XOR. These are the basic or universal functions. Using this you can perform any operation. So this is the compound. As you see, I create an example of this. Like in this case I have numeric, so that I use 4 inputs and 1 output. Control U will minimize the function, and in this I just put the value like 5, 4, 5, 2. It will add all the values. Like in this case the total result is 16, and when I change the mode to multiplication, this result is also changed. Like in this case it is 200. So this is the function of compound, and Boolean will explain in next section. So over here this is absolute value. I just take it and Control H. It will return a absolute value, ABS X. Like in this case I create a control over here and I just put this value 3.22, and over here I have indicator, it will give me 3.22. so absolute value is, you can find out, like in this case I just put negative sign over here, and when I hit on run button it will give me absolute value. Okay, mod of x. Every case you get the value. So this is the absolute value. Then if you round to nearest, so in this case I take same value, but over here it is let 3.22 and round to nearest value. Create indicator. So when I hit on run button, it gives me 3. So I just, in place of 3, I continuously run. I will check the value. It will give me 3.3. In the case, it will also give me 3. 3.4, it give me 3. 3.5, it give me 4. So when I put over here let 4, in this case again it give me 3. When I increase this value to 5, so it gave me again 3, 4. Over here again the value is 3, 8, the value is 3, 9, the value is 3. If it is 3.5, then it is 4. You have to note down this value. Like in this case again 3.5, it is not 4, it is 3. So when I increase this 3.6, it is 4. So when I put 3.5, again 4. 3.4, it is 4. Not 4, it is 3. So when I put 9 over here, the value is 3. But when the value is 3.5, the value is 4. So this is nearest integer value when you use this function. Then we have another function, round towards negative infinity. It will give you always 3. In this case, when I continuous run this, so over here 3, when I increase this 6, 7, 8, 9, it give me only 3 because it is lie towards negative infinity. And when you want positive, in that case first I have to stop the program. So when I use towards positive infinity, when we have 3.1, it will give me 4. Like when I put over here 3.1, it will give me 4 in this case, as you see. Okay, so these are the different functions. Now I unokay the highlight execution so that my program is fast. So till now we discuss about these functions. Then we go to our scale by power of 2. If you want to, here is my n, this is the function, and this is my another function, in this case x and n. X raised to 2, x into 2 raised to n, it will give me x raised to 2 into n. As you see, first I delete this all. So over here I put 2 and this is my 5. So it give me 2 into 2, 4 into 5, 20. As you see, x into means 5 into 2 into is the power. It is the power of 2. As I increase this 3, it give me 8 into 5, 40. As you see, this is the power of 2. So scale by power of 2. Then we go to our data manipulation. In this case, you use these functions like rotate left with carry. These functions are used in microprocessor, or if you want to rotate your function, you can use these functions, okay, for data manipulation. Then we have complex functions. I can use any of these, like first I delete this. So Here is my complex conjugate. First create input, then it will create an indicator. It will give me the complex conjugate. So when I put the value like 2 into 3, 2 plus 3 iota, it will give me 2 minus 3 iota. It is the complex conjugate. Then we have polar to complex. Like in this case, you have to put the value of radius and theta. It will generate a complex number. Like in this case, r is 2 and this is 3. It will generate this value minus 1.9 plus this iota. So this is the case of complex. You can also convert your complex function to, like in this case I have a complex number, this one x plus iota, which is 2 plus 3 iota. It will give me the radius value and theta value. So when I hit on run button, so r is 3.6 and theta is 0.98 in this case. So using these functions you can create your complex number and you convert complex to conjugate, conjugate to complex, or polar to complex, or complex to polar, or real part of imaginary part to polar, or polar to real or imaginary. You can convert any of these. So this is the part of complex number. Then we go to square root. If you want to find out the square root of any number, like I just take the square root, create control, this is the indicator, and when I want to find out the square root of 6, it will give me the value 2.44946. And also you can change the digit value also, like display format. Just right click on this, and in this case it is 6 digit. If you want more, you can get any value, like over here you can increase. Okay, so this is the case of square root. I just delete this. According to this, you can find out your square, negate if you want to negate the value, if you want to find out the reciprocal of some value, and if you want to change the sign, like in this case if we have a number and we have an indicator, if I put 0 like 2, it gave me -1, because in this case the range is -1, 0 and 1. If I put -2 over here, it will give me -1. If over here it is 2, it is 1. So extreme limit is -1 in negative case and 1 in positive case. If I put over here 0.5, in this case it give me 1. Okay, and when I put minus 0.5, it will give me -1, as you see. So this is the higher limit and this is the lower limit in case of sine. So this is the scaling part. Over here, if you have any sensor and you want to convert your RTD, resistance temperature detector reading, you can use this VI. And if you want to convert strain gauge reading, you can use this one. If you want to convert thermistor readings, you can use this one. This is the inbuilt VI in LabVIEW. And if you want to convert your readings from degree to radian and radian to degree, or RPM to radian per second, or radian per second to RPM, you can use these functions. These are the inbuilt functions in LabVIEW in Numeric Pallete. So then we go to some other parts. Over here, this is the numeric integer type constant. This is the nm constant. So over here you can create any integer type, like in this case I just put some value. First right click on this, edit items. You can put anything in this, like in this case insert, like I put the value Sam, then we have Ram, then we have another. Okay, you can insert any value and according to this it will work. So this is the nm constant. You can use this in your program. Basically this is used in state machine programs. Then we have ring constant. Over here again, if you control H on this, there is no description available about this. I will tell you in further classes what is ring constant. So over here we have a random number. This random number will generate the values from 0 to 1. Any value from 0 to 1 like 0 0.456, 0 0.345. So this is equivalent to rand command in MATLAB. Another random number, in this case you can set the range, upper bound limit and lower bound limit, and also you can change the formatting or representation like u64 unsigned number. U stands for unsigned number, integer 64, or dbl floating type. Okay, so over here like example, in this case I create a control. The default value is 100. Again I put lower limit 100. In this case it will generate a integer value because it is set to integer. If you want to convert to floating type, you can select dbl. So when I hit on run button, it will generate a value from 0 to 100 between like 53. And if I change this value 0 to, in this case the value is changed, any value, random value. Okay, so this is the case of random number. Then we have fixed point. You can use for fixed point to integer cast or integer cast to fixed point. You can use these functions. These are rarely used in basic programming. So then we have, here we have integer constant, here we have floating constant. Its color is orange. Then we have some constant like positive infinity, negative infinity, epsilon, not a number constant. In this case you can put any value like it is not a number, nan, not a number constant, and some another constant like pi, 2 pi, pi by 2. These are the fixed constant already created in LabVIEW. You can use directly in your program. So these are, and most important part of numeric palette is expression. If you want to create an expression in which you have only one expression, like one variable, not expression, one variable, like sine of x into sine of x by 2 into sine of x by 4 into cos of x, then you use this function like sine of x into sine of x by 4 into sine of x by 2. So it will give you the value, create control, and over here integrate. So you can create your expression. Over here you can put the value of x, it will give you the value. Okay, you can use this numeric palette for your expression. So this is all about numeric palette in LabVIEW. You can use or you can create any mathematical expression using this, or you can create any equation using this palette. Okay, so this is the part of functional palette, and in which programming we have numeric palette. In the next part we will discuss about Boolean palette. Okay, thank you.